Hi everybody. Today you're going to be working on the assignment Calculating Speed from a Distance Time Graph. Now remember in the notes we learned that if you have distance on the y-axis and time on the x-axis, the steepness or slope of the graph represents the speed the object's going. And of course, the steeper the slope, the faster the object's going. Now what we're going to learn how to do today is correctly find slope of a distance time graph, okay? This requires us to pick 2 points that are on the graph line and get their coordinates. Then we use the slope formula, y2 minus y, oops, I got that backwards, don't I? That should say y2 minus y1. I did them all wrong. Look at that. Well, you all can fix it yourselves. x2 minus x1. You always say final minus initial, final minus initial. 2 minus 1, 2 minus 1. But the point is, the y's go on the top. That's these, okay? X, Y, X, Y. The y's go on the top, and the x's on the bottom. So right here, I'm just going to go ahead and label these. For point 1, we have x1, y1. And for point 2, we have x2, y2. And then we're just going to stick them in, okay? And then crank out an answer. So let's take a look at this. The first thing we have to do is actually pick 2 points. Now, just pick 2 convenient points that you can easily determine the coordinates from. So let's look at this one. This particular graph line has a number of easy points we can choose, okay? We can choose the very first point, if you wish, and the very last point. We could also pick just about any of these points where the line goes through what I call the crosshairs. That way you can follow down, like if I picked this one, I could follow down and see what the x value is, and I can follow over and see what the y value is quite easily, okay? So that's how we kind of conveniently choose points, ones that are easy to determine the coordinates for. All right, so I'm going to use this first one and last one. Those are always convenient. So the first one, the x value along the x-axis, this is 0, isn't it? So right here, we'd put 0 for that one, okay? The y value up the y-axis, it goes 0, and here's 4, so halfway between, this has to be 2, doesn't it? 0, 2, 4, 6, 8, 10, 12. They've only numbered every other one because if they numbered every one, it would be just a big mess right here. There'd be so many numbers. So they only did every other one to make it easier to read. So from 0 to 4, halfway between, that would have to be 2, so we put a 2 there, okay? Now let's get the second point. Come up here. First, we follow down to the x-axis. Always do the x first. Halfway between 10 and 12, that would have to be 11. Okay, again, they didn't number every single line because you'd have too many numbers. It'd be crowded and look messy. So this is 11, halfway between 10 and 12. So over here, put 11. Okay, now, from that point, we're going to go over to the y-axis. Oh, 24. Oops, sorry about that. 24. So we come over here and put 24 right there. Now that we've got our 2 points, we can find the slope. So, y2 minus y1 over x2 minus x1. Okay? So, here's y2. That's going to be 24 minus y1 is 2 over x2, see, x2 minus x1. All right, so now let's use our calculator. Well, in this case, I don't think we have to. 24 minus 2. Well, 24 minus 2 would be 22, wouldn't it? 11 minus nothing would be 11. Okay, and what is 22 divided by 11? Well, it would be 2 meters per second. How did I know it was meters per second? Because the y values on top came from the y-axis, which is distance in meters. So we put meters here. The x value came from the x-axis, and that's time in seconds. So this would be seconds. So we get 2 meters per second for the speed. Okay? That wasn't so hard, was it? I'll do one more. One more doesn't look quite so easy to do, all right? How about that? I tell you what, number 2 is not so bad, but I want you to look at number 3 for a moment. It slants the other way. So why don't we do that one together? All right? You can easily do number 2 yourself because it's very similar to number 1. All right, so let's look at this one where it slants this way instead of this way. Now that doesn't change the fact that the slope represents the speed. This just means that the object is coming back towards the reference position of 0, okay? So now, the first thing we have to do to calculate the slope or speed is to pick 2 points on the line. So let's find 2 convenient points. Well, if you'll look, there's a point right there that looks good because it's right on the crosshairs right there with the y-axis and this line. And look at this one right here. I think I'm going to choose that one. Okay? Because it goes right through where the x and y lines cross. Makes it easy. Now see, if I picked one like right here or right there or right there, that would be hard to find other values for. For example, this one, I could see the x value, but I'd have to estimate the y value. This one, right here, I could see the y value, but I'd have to estimate the x value. So it's easier to pick a point where the line actually goes through where the x and y lines cross, because then for that point you just follow them over. See? That's not so tough, is it? Okay. So let's look at these 2 points. Point 1. All right. Point 1 is on the 0 for the y-axis, so for the x-axis. So it has a 0 of x. There's no over, all right? It's just right there at 0. But then we go up the y-axis to 120. So it's 0, 120. And in fact, let's renumber these again. x1, y1, x2, y2. If you do that each time, then it's easier to plug in right there, okay? Now, that's our first point. Let's get our second point. Here it is. Let's do the x value first. Down here on the x-axis, it has a value of 15. So we put 15 in the x spot. All right, then following over the y-axis, it has a value of 80. So that's y2. So now we're going to take the coordinates and we're going to plug them into the slope formula. So, and again, remember, this really should be y2 minus y1 over x2 minus x1. I don't know how I think I was just thinking 1, 2, 1, 2, but it actually should be the other way around. I think I was trying to count like 1, 2, 3, but it should be y2 minus y1 over x2 minus x1, and you can fix that yourselves on the paper. Okay, so now y2 would be 80 minus y1, which is 120. And yes, I know y1 is bigger. Don't worry about it. x2 is 15. And x1 is 0. All right, so here's what we get. Now, if we say 80 minus 120, we get negative, because that one's the bigger one, we get negative 40. Okay? Negative 40. How about that? All right, now, we're going to divide that by 15 minus 0. 15 minus 0 is just 15. You're not taking anything away, actually. So we get negative 40 from the top, and that's going to be in meters because that was the y-axis, over 15 on the bottom, which would be seconds because that was from the x-axis. So the speed is going to be whatever 40 divided by 50 is with a negative on the front. So we take our calculator. All right, this is the easy part. The calculator is going to do the work here. 40 divided by 15. All right, see that? Okay, let's see what it gives us. 2.66 repeating. So if you wish, we could round that to 2.7. That would be perfectly acceptable. So we get negative 2.7 meters per second. Now, what does the negative mean? The negative means it's just going in the other direction. Just means it's going back towards the reference position. Remember, we always measure from a reference position, typically 0. So that means the object is just moving back towards the reference position instead of away from it. That's all that means. Okay, so I've shown you 2 examples. One where the slope is positive, it's traveling in the positive direction, and you get the magnitude by picking your 2 points, chucking those coordinates into the formula, subtract on the top, subtract on the bottom, and then divide, and that gives you the speed, okay? And you're going to do number 2, and then on the back side, you've got 3 more. Notice there's another slope right here where you're going back the other way, so that'd be very similar to the one we just did. And then the last 2 are like the first 2. You're going away from the reference. All right, but I want you to practice picking 2 points. And remember, each time you do this, for point 1, make this x1, y1, and for point 2, x2, y2. It's always x comma y. So we differentiate the x's by making point 1, x1, point 2, x2. We differentiate the y's by saying, point 1 has y1, point 2 has y2. All right? Then we know where to stick them, as long as we remember to switch this, because brilliance here put it in backwards. That wasn't too smart. In fact, before you start working, I would go through each of these and switch those 2 subscripts, all right, so that they're correct. y2 minus y1 over x2 minus x1. So finding the slope of a graph is actually very easy. And in the case of a distance versus time graph, the slope physically represents the speed of the object, how fast it's moving. Okay, have fun with the others, and I'll talk to you later. Bye-bye.